Okay, first question we had was number 6. Really? You guys don't have more questions on these?
This is the only thing I know how to do.
Oh, stop it. Okay, remember, we cannot do the antiderivative of a product or a quotient, so you have to simplify things first. We could write this as 10 times 2x plus 3 to the negative 2 power. So an antiderivative adds 1 to the power. All right, we still have this 10 in front. It's not going anywhere. Then if this power is negative 1, you have to multiply by
Negative.
Yeah, reciprocal of negative 1 is just negative 1. Think about when you do this derivative, you'd have to do the chain rule. So derivative of the inside is 2. To cancel that, we need 1/2. So this would be a negative 5, 2x plus 3 to the negative 1. And we are evaluating that from 1 to 3. Right, you can take out the negative 5 if you want. So if I plug in a 3, I get 9 to the negative 1, so 1/9. Minus, if I plug in a 1, I get 5 to the negative 1, so 1/5. Just for fun, let's do this. So if we distributed, I don't know, let's subtract. Let's practice our fractions. 1/9, that's like 5 over 45. 1/5 is 9 over 45. So you get positive coordinates. Is that one okay? Problem number 8. Alright, so we have to simplify this before we do anything else. So if you FOIL the top, you get 16 plus 8x. Square root of x squared is just x over 2 square root of x, or you can think of that as 2x to the 1/2. We can't do a quotient in reverse, so we will first split this up. So 16 over 2x to the 1/2 would be 8x to the negative 1/2. 8 over 2 is 4. X over x to the 1/2 would be x to the 1/2. X over 2, x to the 1/2 would be 1/2 x. What did I mess up?
Well,
I dropped a square root, didn't I? Yeah, I dropped my square root right there. So then, those are gone. Alright. Is everybody with me here? So antiderivative. Okay, this 8 just stays. So if you add 1 to the power, that's a positive 1/2. You put the reciprocal in front, so that's a 2. So we get 16x to the 1/2. 4, that would just go to a 4x. So this one. If you add 1 to the power, that's 3/2. Reciprocal in front is 2/3. Times 1/2 is 1/3 x to the 3/2. We are evaluating this from 1 to 4. Alright, so then we plug in remember you do the top minus the bottom. So square root of 4 is 2 times 16 is 32 plus 16. Square root of 4 is 2, cubed is 8, so that would be 8/3. Minus 16 plus 4 plus 1/3. So 48 minus 20 is 28 plus 7/3.
So 148.
Is it?
That's what I got, and it gave me the right answer, I think. Actually, I don't know if it's the right, what's the right answer?
91.
Oh, then it's not that, actually, because I got 87/3.
Still got over 3.
So you just had a calculation error. You had all the right work. All right. Is this one okay? All right. Next step. So you guys were good on number 9. All you're doing is the antiderivative, but you had the information to find your constant. Okay. So next page, we really don't want to go over any 10 through 14.
I really did good.
Your summation formulas. Good. All right, so problem 15. It tells us that f of x is 9 minus 4x. We want to find the area on the region from 1 to 2 by first computing the sum from 1 to n f of x sub I times the change in x. So if I'm going to do this, I have to find change in x and x sub I. So what is my change in x? 2 minus 1 over n, so 1 over n. X sub I is your beginning point plus the change in x times I. So when it says f of x sub I, that means you're going to take x sub I and plug it in for x in this equation. So we get 9 minus 4 times the 1 plus 1 over n I times change in x, which is 1 over n. All right, so this is more than just a bunch of symbols. This right here tells you exactly what you're doing. You're plugging x sub I into your equation. You're going to multiply by the change in x. Now we have to do the summation stuff. So before we can add this up, we need to multiply things out. So we would get 9 minus 4 minus 1 over n I times 1 over n. So this would be 5 times 1 over n, so 5 over n minus 1 over n squared I. Hold on, I dropped a 4, didn't I? That should be a 4 right there. Okay, so now the summation rules. 5 over n, since that doesn't have an I, it's a constant. So when you add that up, you're adding it every time, so you just multiply by n. Minus 4 over n squared. The I formula is n times n plus 1 over 2. So I get 5 minus, I can cancel an n. So this would be 4n plus 4 over 2n. So I get 5 minus 4n over 2n minus 4 over 2n would be 2 over n. So this simplifies into 3 minus 2 over n. Then if you look back at the problem, it says, and then take the limit as n approaches infinity. So now we want to do the limit as n approaches infinity. So we get 3 minus 2 over infinity goes to 0. And we get 3 for our answer. Okay. So I know the struggle has been like how to remember what you're doing. Just pay attention. It looks like a bunch of crazy symbols, but it's telling you exactly what to do. Take a second to think about that. All right. number 17. All right, it's really tempting to just do the antiderivative on this because now we know how. But it tells you to find this value by computing limit as n goes to infinity of the sum from 1 to n of f of x sub I times the change in x. So let's do what this says. We have the limit as n goes to infinity. Sum from 1 to n. All right, we need to figure out what x sub I and change in x are. So my change in x is what?
5 over n.
Right, 5 minus 0 over n is just 5 over n. X sub I, you're starting at 0 plus your change in x times I. So you just get 5 over n I. So f of x sub I says you go to your function. You replace x with x sub I. So we have 2 times 5 over n I cubed minus 4 times 5 over n I squared plus 5 over n I plus 1. And we're multiplying this by the change in x, which was 5 over n. Is everybody with me here? So we need to do a lot of calculations. I'll try to show my work so you can understand where everything's coming from. So 5 cubed, 5 times 5 times 5 times 2 over n cubed I cubed minus 5 squared is 25 times 4 would be 100 over n squared I squared. 5 over n I plus I'm going to distribute my 5 over n now. So 250 times 5 would be 1,000 n to the 4th I cubed minus 500 over n cubed I squared 25 over n squared I plus 5 over n. Now we can do the summation. All right, what's the I cubed formula?
N times squared.
Okay, what's the I squared formula? What's the I formula?
N times n squared.
And what do you do about constants? Okay. So we are cleaning all of this up. All right, 1,250 divided by 4. We'll go to 625 over 2, right? Okay, I can cancel out an n squared pretty easily. And then I have to FOIL this n plus 1 squared. Let's see, I can cancel this 1 in here, 500 over 6, 250 over 3n squared, and FOIL. Is everybody still with me? So now I'm just going to break all these parts. So 625n squared over 2n squared would be 625 over 2. Plus 625 times 2n over 2n squared would be 625 over n. 625 over 2n squared. Alright, this one we need to distribute, think of it as a negative 250 that I'm taking through here. So we would get minus 500 over 3n minus 250 over n minus 250 over 3n squared.
Is it not just 500 over 3?
Yes, it would be, sorry. This one we get 25n over 2n, so 25 over 2. 25 over 2n. That's the same. Okay, now we do our limit. Anything with an n on the bottom is going to turn into 0. And this gives us a pretty ugly answer. It was 490 over 3, I believe. Okay, so the math was longer there just because we had such a long polynomial and we were using all of our summation formulas. Questions on that one? Next question is number 19. So my function is x cubed minus 1. My interval is 0 to 5, and n equals 4. And I asked for left, right, and midpoint sums. So, first step, change in x. What would it be? 5 minus 0 over 4, so 5/4 or 1.25 if you like doing the decimals on these. Either way is fine. All right, so let's think about this. My first interval will start at 0. It will end at 1.25 because that's my change in x. Okay, so when I ask for the left hand sum, which of these points is on the left?
0.
0. So we'll start with the 0. Now remember, we're adding up rectangles, right? So rectangle, every rectangle is length times width. What's the width of all of these rectangles? 5/4 or the 1.25, the change in x. So we're going to multiply by that. So then we need 4 rectangles here. All right.
So left, is that the under or over?
It kind of depends. So one way of checking is when you actually calculate them, the bigger one is the over and the smaller one is the under. You could draw the curve, so x cubed minus 1 is going to be like your chair function. So if you think about that, that's increasing. So if you're starting here, then it would be below your curve, so this will actually be the under approximation on that. So to get these, we're starting with 0, and you plug it into your function. So 0 cubed minus 1. And then to get the next one, you add your change in x, so 1.25 cubed minus 1. Add our change in x, so 2.5 cubed minus 1. Add our change in x, so 3.75 cubed minus 1. And if you do this, you get 82.891. So next, let's do the right hand side. So if we're dealing with this interval, which point is on the right?
5/4.
Yeah. Well, that's 5/4. It's the same. So the difference is we aren't starting at 0. The first one I plug in is the 1.25, but then we have 4 total points again. So I start by plugging in the 1.25 cubed minus 1, and then add your change in x. So 2.5 cubed minus 1, 3.75 cubed minus 1. Your final one, change in x, if you add it one more time, you get 5 cubed minus 1, which was the right endpoint. And when you add that one up, you get 239.141. So we can also see the left was small and the right was big. So the left was my under, the right was my over. So now I ask for the midpoint. Okay, my change in x is still the same. So I'm still multiplying by my 1.25. And we're still adding 4 things up. To figure out where to start, in this interval, 0 to 1.25, we need the middle. So what number falls in between these? 5/8. Or if you were doing decimals, that's 0.625. So either one is fine. So that's the first one you plug in. And then you add your change in x to get the rest. So if I add my 1.25, I get 1.875. Add my change in x, so 3.125. And add my change in x, and I get 4.375. And that one should fall somewhere in between the left and the right, and it does. It's 146.367. Is that okay? All right. Let's talk about the back page, the old stuff. It's been a while. So number 20. We are making a box. The base length is 6 times the width. So if I called this side W, this side would be 6W. And it doesn't tell me what my height is, so I'm going to call that h for a second. It tells me the box will enclose 20 cubic inches. That's my volume. Volume is length times width times height. So if I multiply these, W times 6W times H, that has to equal 20. So if we solve for H, you get 10 over 3W squared. Now we need that because we don't want multiple variables. Okay, I don't want W's and H's. So instead of H, I'm going to call this 10 over 3W squared. Now, it's asking me to minimize the cost, so we have to calculate the cost. You basically have 6 sides of this box, so we have to figure out the cost for everything. The top and bottom cost $15 to make. So the cost is $15. If I do both of those, top and bottom, so there's 2. And then we need to multiply by their area. So what's the area of the top and the bottom? All right. The sides cost $3. So let's start with the left and right. So there's 2 of those. So if I'm trying to find the area of these, you have to do 6W times the 10 over 3W squared. And then we have the front and back. Those also cost 3. There's 2 of them. So if I calculate this area, those are W times 10 over 3W squared. Okay, we need to clean this up a lot. So 15 times 2 is 30, times 6 is 180 W squared. And this one, I could cancel a 3, I could reduce a W, so I get 120 over W. Okay, this one, reduce the W, reduce the 3, and I get 20 over W. So my cost is 180 W squared plus 140 over W, or I'm going to write that as 140 W to the negative 1. Anytime I ask you to maximize or minimize, what do you have to do? What equals 0? Derivative equal to 0. So my derivative is 360W minus 140 W to the negative 2, and that equals 0. 140 W to the negative 2. That means 140 over W squared. So if I multiply my W squared over, this one is not nice.
How did you, okay. I think I got messed up. Because I had 360W minus 150.
So you add something on. Should have been a 140. This is a 20 right here.
Yeah, 140. But I don't have that little W to negative.
Okay,
2.
because this was 140 divided by W, which is like 140 W to the negative 1. When you do the derivative, you subtract 1 from the power.
Subtract. Why did I think it was add?
That's the antiderivative you add. Okay, so we get W cubed equals 140 over 360. So cube root, it is not pretty. And it gives you about 0.73. So it's 0.73 inches by the width is 6 times this. So 6 times 0.73 is 38 inches, and the height, if you plug your W into the 10 over 3W squared, you get 6.26 inches. Let's look at 21. So a concert promoter has found that if she sells tickets for $50 each, she can sell 1,200 tickets. But for each $5 she raises the price, 50 less people attend. When you set this up, X has to be the number, Y has to be the price, because we're making a price equation. So the number of tickets was 1,200 and the price of those was 50. If she raises the price $5, so the price is now 55, we lose 50 people. So that's 1,150. So we need to find the equation of this line. So we get a slope of -1/10. Take one of your points, plug into y equals m times x plus b. So b equals y, 170. So our price is -1/10 x plus 170. I strongly recommend labeling these equations on those problems. That'll help you a lot. Then I want to maximize revenue. How do we get revenue from here?
Times by x.
So the revenue is -1/10 x squared plus 170x. Okay, if I want to maximize this, we need derivative. So bring down the 2, so that's -1/5 x plus 170. Anytime we maximize or minimize, its derivative equal to 0. So we get 850. That's my x. The question was the price. So now I have to plug the 850 into this price equation. So -1/10 times 850 is -85 plus 170. And we get that the price should be $85 a ticket. All right. Could we handle something like that? We did quite a few of those when we were optimizing, so. All right, L'Hopital's. Remember, L'Hopital says if you have 0 over 0 or infinity over infinity, we can do the derivative of the top and bottom, and it will give us the same thing. So A, limit x approaches 0 of 5x over 2 e to the x minus 2. So if we plug in a 0, 5 times 0 is 0. E to 0 is 1, so 2 minus 2 is 0. So it's currently 0 over 0, which means we can do L'Hopital's. Remember I asked you to label that when you did it? We just put that LH. So we're not doing quotient rule here, it's just the derivative of the top, which is 5. Derivative of the bottom, so that would just be 2 e to the x. Right, now if I plug in, the top is 5, the bottom is 2 times e to the 0 is 1. So we get 5/2. B. All right. X to the -4, that's like 1 over infinity. So that's going 0. Natural log of infinity is going to infinity. So 0 times infinity, that's an indeterminate form. We can't do L'Hopital's until it's an indeterminate quotient. So how could I write this as a quotient?
Or natural log of x
Right, a negative exponent just moves it to the bottom. So now it's infinity over infinity, which tells me we can do L'Hopital's. So, derivative of the natural log x. Derivative of x to the fourth.
3x or 4x.
If you want to clean this up, we don't really like fraction and fraction. Just think, if you took top and bottom times x, that gives you 1 over 4x to the fourth. So then, this is 1 over infinity, which is 0. All right. Remember, there were like 4 main types, so that's why I tried to put on here. The ones that were quotients to begin with, the indeterminate products, where we have to write them as a quotient. Next type were the indeterminate sums and differences. Okay, if I plug in 1, that's 1 over 0, so that's an asymptote, so it's an infinity minus natural log of 1 is 0, so it's infinity over infinity. We have to get this as a single fraction before we can do L'Hopital's. So what do we have to do? So the first one needs a natural log x. And second one needs x minus 1. Okay. I put these together. We get the natural log of x minus x plus 1 over the natural log of x times x minus 1. All right, let's see. So natural log of 1 is 0, minus 1 plus 1, so that's 0, and 0 times 0 is 0. So it's currently 0 over 0, which means now we can do L'Hopital's. Derivative of a natural log is 1 over x, minus derivative of x is just 1. What do we have to do on the bottom? Product rule. So derivative of the first, derivative of the natural log is 1 over x times the second plus the first, derivative of the second. All right. Fairly ugly right now. We could use that trick I did in the last one. Since we have so many fractions within fractions, you could say I'm just going to multiply by x on top and bottom. So we get 1 over x times x is 1. 1 times x is x. Okay, if I take this x to each term, then it would cancel that 1 over x, so we get an x minus 1. Plus, that would be an x natural log of x. So if I plug in 1 minus 1 on top is 0, on the bottom 1 minus 1 plus 1 times 0. So it's still 0 over 0. So what does that mean? L'Hopital's again. Derivative of the top? On the bottom, derivative of x is 1. Minus derivative of 1 is 0, so that goes away. The x, natural log of x, we have to do the product rule. So derivative of the first times the second plus the first derivative of the second. Okay. So on the bottom, x times 1 over x is 1, plus 1 is 2 plus the natural. So it's negative 1 over 2 plus the natural log of 1 is 0. And we finally get negative 1. Got 5 minutes. Let's try the last one. If I plug in right now, I have 1 to the infinity power. That's indeterminate. How did we do the indeterminate powers?
Change it to like natural law.
Yeah, we added a natural log because properties of natural logs, the exponents come down. So this is 1 over x, the natural log of 2x plus 1. Or that one is easily written as a fraction, natural log of 2x plus 1 over x. Now, if you add a natural log, what do we have to do at the end? We have to do e to cancel that natural log out. Okay, so if I look at this, I have the natural log of 1, which is 0, over 0. So that's an indeterminate form, so we do L'Hopital's. Alright, on the top, derivative of a natural log is 1 over the argument. But we have to do chain rule here, so times derivative of the inside, which is 2, over derivative of the bottom, derivative of x is just 1. So we get 2 over 2x plus 1. Plug in a 0, so that's 2 over 1, which is 2. So my answer is